In this video, we're going to take a look at how to graph parametric equations using the TI-84. Let's jump right into it. We should know what a parametric equation is and what a set of parametric equations looks like. Let's say we have this pair of parametric equations where the x value is given by t squared minus 4 and the y value is given by t over 2. This was an example number 2 in our parametric equations lecture. So if I want to do that, if I want to graph this set of parametric equations on the TI-84, what I have to do is obviously turn on the calculator. And then what I'm going to make sure I do is I'm going to make sure I'm in the parametric mode. So I go to mode, and then on my calculator, the fifth down is function, parametric, polar, and sequential. So we're talking about parametric. Make sure that's highlighted. Once I do that, I can either go back to the home screen or I can go right to the graphing. We hit y equals now, and instead of getting y equals, we end up getting this look. And basically, each pair of equations sets up a parametric equations for us. So if you recall, we had our x as t squared minus 4. Since we're in the parametric mode, when I hit my variable key has x on it if I'm in function mode, but it has t on it if I'm in parametric mode. So it'll say t and then squared minus 4. That was my x value. And then once again, I hit t and then over 2. That was my y value. Now I'm ready to graph this. Now you can either adjust the window or do a zoom or hit the graph button. There's lots of options there. But what I'm going to do right now is I'm just going to hit zoom and then I'll do the standard number 6 there. As you can see, it graphed part of this. It turns out this didn't actually graph the entire thing, and the reason it didn't graph the entire thing is because if I hit trace, my t here starts at 0, and it doesn't go any lower than 0. If I want that t value to go lower than 0, all I have to do is adjust the window. So hit the window. You can see that the automatic values for t go from 0 to essentially 2 pi. So let's say we want to go from -10 to +10. And then if you want to adjust your step to make it a little bit finer tuned, you can do that. Then hit the graph. Once you do that, it's going to take a minute because that step is so small that it's going to take a little while to graph, but now you can see the graph. If I want to find the orientation of this graph, all we have to do is hit trace. And then as I hit the right arrow on my calculator, you can see that the t value increases and you get the corresponding x and y coordinates. So obviously it's going to take a minute to get to a place on the graph because it takes so long. Maybe you could just hit trace and then let's say -5. That might be, yeah, even too much. Once we get down to about -3, then we can see our point on the graph. And you can see that the orientation is that as this point moves from below, we're moving to the left, hitting that vertex, and then moving back to the right. So that's how this is drawn. Again, the reason why it's taking so long is that when I was in my window, my T step was very small. If I made this a little bit less small, then first off, it's going to graph faster. And second, when I hit trace, my jumps are going to be 0.5 instead of 0.01. So there you go. That's how to graph in parametric mode. And this is also how you can find the orientation. You can see how my point moves around the graph. So in this case, for negative t values, it was moving left. And then once it got to the vertex, then it became positive t values and it was moving back to the right. Let's do another example. Here was another example of a set of parametric equations. The notation was slightly different. We had x of t equals 2 cosine of t minus 4. And then y of t is equal to -5 times sine of t plus 1. If I wanted to graph that on my calculator, once again, I just make sure it's in parametric mode. I hit y equals, and then I type in my equation for x. Let me clear that one out. 2 times cosine of t, make sure we're using just the variable key here, minus 4, and then -5 times sine of t, again, the variable t, plus 1. And if I graph that, you can see that I get an ellipse. Obviously, if I wanted to change my window in this case, it might be appropriate to make my t value go from 0 to 2 pi with that, let's say a step of 0.5. But you can also kind of see how this is graphed as well. If I want to see the orientation, then I just hit the trace key and then I trace around. So notice in this case, the orientation is that the point is moving in a clockwise direction. If you start at 0, that point is moving in a clockwise direction. Okay. There's other stuffs you can do as well. You can calculate, value. That's basically what happens with the trace. Notice that anytime you input a t value, you get the corresponding xy coordinate there. I'll do this one. Um, we saw some other interesting curves, one of which was this hypotrochoid, which had x is equal to 2 cosine t plus 5 cosine of 2t over 3, and y equals 2 sine of t minus 5 sine of 2t over 3. I just wanted to point that one out because obviously we get this star shape. If I go to graph that, I'd write 2 cosine t plus 5 cosine of 2t over 3. That's my x. And my y is 2 sine of t minus 5 times sine of 2t over 3. Now, if I graph this, I get the hypotrochoid that I want as long as my window is correct. Notice that if I go from 0 to 2 pi, I just get this portion of it. That was because the window went from 0 to 2 pi. Obviously, I want to go more than 2 pi. I think if we go out to 10 pi, that should be enough. But you can see also how this is being drawn and the orientation of how this works. So we get this star shape. For my window, it looked pretty good. Obviously, because of the window, it's a little bit skewed further in the width than the height, but that's just because of the screen of the TI-84. If you wanted that to be more square, then you could hit the zoom square button there and have it draw. And now it's going to look a little bit more proportional. The width and height are going to look more proportional. So that's another example of a nice curve we could draw. And as you can see, this one is pretty well done. It's pretty smooth. Doesn't have a lot of jumps. One thing to watch out for is that if you utilize some curve that's doing a lot of loops or a lot of jumps, and your step is pretty big, let's say my step is, I don't know, 0.35, then when I graph it, it might not look as smooth. This one did. This one looked pretty smooth right now at 0.35. But if we did something like, let's say 0.9, you can see it gets a little bit choppy as I graph it. So if your graph does look choppy, like where there's a bunch of connected dots, like a kindergartner was trying to connect the dots, then probably messing with your step, making that a little bit smaller would be helpful. So making that step a little bit smaller oftentimes becomes pretty helpful. And obviously, when we can do that, when we want to trace this, we can trace and see how the point moves along that hypotrochoid. So that's how to graph in parametric form. Okay, we've graphed a bunch of these. Obviously, some are easier to see than others, but these were all examples that we saw in our lecture on parametric curves in the plane.